Hello guys, good morning. You are welcome to my YouTube channel, The Explicit Tutors. As you all know, I'm Mr. Explicit or Tutor Joseph, all right? So it's been a while I uploaded the content on my YouTube channel because my phone got bad, but I think I am back, all right? Yes, I am fully back, as John Wick said. I think I'm back. All right, so in today's video, we shall be discussing a topic, acids, bases, and salt. Acids. Acids, according to Arrhenius, are substances that dissolve in water to produce hydrogen ion as the only positive ion. It says that when acid dissociates or when they dissolve in water, they produce positive hydrogen ion. For example, if HCl should dissociate, I'll be having H plus and Cl minus. So H plus here, it's the hydrogen ion that is what? Positive, according to what Arrhenius said. So acid is a substance that dissociates to produce hydrogen ion as the only positive ion. All right, moving from there, he also said that acid is a substance that dissolves in water to produce hydrozonium ion. So this H3O plus is the hydrozonium ion, all right? Acids is a substance or are substances that dissolve in water to produce hydrozonium ion as the only positive ion. It said that acid is also a substance that dissociates to produce hydrogen ion as the only positive ion. So moving from there, we also have different acids whose proticity or basicity is 1. Take for example, the one we've just done. If this guy should dissociate, we have H plus. Now the question is, what is proticity or basicity? It is very easy. It means the number of replaceable hydrogen ion present in a compound. When you have 2, it is dibasic. When it's 1, it is monobasic. When it's 3, it is tribasic. What about polybasic? A polybasic acid is an acid that dissociates more than once to keep producing hydrogen ion per molecule. Let's take this. It means already HCl is monobasic, right? Then HNO3, for example, I'll have H plus NO3 minus. It is also what? Monobasic. What about H2SO4? If it should dissociate, I'll be having what? 2H plus and SO4 2 minus. It means this one is what? A dibasic. It means it is what? Dibasic. What about CH3COOH? What is the basicity of ethanoic or acetic acid? It is also 1. All right, CH3COO minus. If this guy should undergo dissociation, it is not this one that is removed, it is this H here. So acetic acid is monobasic. H2SO4 is dibasic, monobasic. Another example is the ethanol 2-dioic acid. If this guy should dissociate, you see, this 2H plus means that it is what? Dibasic. Now, I made mention of polybasic acid. A polybasic acid is an acid that dissociates more than once to produce hydrogen ion per molecule. Look at it here. A good example is H2SO4. If H2SO4 undergoes partial dissociation, I'll be having H plus, then plus HSO4 minus. If this guy dissociates further, I'll be having HSO4 minus, then another H plus plus SO4 2 minus. So H2SO4 is a polybasic acid. Hope is very clear. Now that is for Arrhenius. Arrhenius said that a base is a substance that dissociates to produce hydroxyl ion as the only negative ion. It said a base is a substance that dissociates to produce hydroxyl ion as the only negative ion. So if I have KOH and NaOH, if these two guys should dissociate, I'll be having H plus OH minus, N plus OH minus. So this is what is responsible for the basic property of this compound. So in conclusion, Arrhenius says that an acid is a substance that dissolves in water to produce hydrogen ion, or is a substance that dissociates to produce what? Hydrogen ion as the only positive ion. It said a base is a substance that dissociates to produce hydroxyl ion as the only negative ion. That is for Arrhenius. What about Anthony Antion Lavosa? Anton Lavosa says that as an acid is a binary compound of oxygen, is a binary compound of what? Oxygen, meaning that oxygen is responsible for the acidic property of a compound. However, after his postulation to have said that an acid is a binary compound of oxygen, it was disproven, or it was countered by a scientist called Davy. Davy said that, young man, you are very dull. He said, how can oxygen does that? He said, it is not oxygen that is responsible for the acidic nature of an acid. It is what? Hydrogen. So he used HCl, just as we initially illustrated, H plus and Cl minus. All right. So Davy was the scientist that corrected the definition of acid by Anton Lavosa. All right. So please take note of that. The next one, please please note this. Now, our concept of salt, of acids and bases in aqueous solution, our knowledge of acids and bases in aqueous solution was put forward by Davy and Lussac. Our concept of acids and bases in aqueous solution was propounded by Davy and Lussac. For example, we have what is called a neutralization reaction, a reaction between an acid and a base to produce salt and water only. Look at it here. If I have H2SO4 reacting with NaOH, what would I have? This will react with this. I have Na2SO4 plus water. It is a reaction between an acid and a base to produce salt and water only. All right. I can also react H2SO4 with potassium hydroxide, which is another type of base. So we have K2SO4 plus what? Water. Isn't that correct? We can also react this with HCl and this with HCl to get sodium chloride and potassium chloride respectively. So that is all about Davy and Lussac. However, how did Bronsted and Lowry define acid and bases? Bronsted and Lowry. Bronsted and Lowry said that acid is a proton donor. Did you hear that? Bronsted and Lowry said that an acid is a proton donor, all right? And he said that a base is a proton acceptor. Now, if he said that acid is a proton donor and a base is a proton acceptor, how do you illustrate that? Look at it. If I have HCl reacting with water, for example, this guy is acting as an acid here, and this guy is acting as a base. Now look at it here. Said acid is a proton donor.
Yes, sir.
Then a base is a proton acceptor. Now, if this guy as a donor is giving out H, if it does that, I'll be having H3O plus, then Cl minus. You see, acid is a proton donor. Then a base is a proton acceptor. It has accepted the H given by HCl. Another example is NH3 plus what? HCl. This is acting as a base, acid, and base. A proton donor. A proton donor. Okay, sorry. This is an acid and this is a base. A proton donor. So this acid is giving off the H, and I'll be having base to be NH4 plus, then Cl minus. This is ammonium ion. So please, acid is a proton donor, base is a proton acceptor. So it's accepting proton from this guy, and this one is giving this one is accepting H from this one. So this is the base being the acceptor of proton, while this one is the acid being the donor of what? The proton. So we can also have that NH3 plus HF. If I do that, what will I have? This is acting as a base. This acting as what? As an acid. So it's giving out H. I have NH4 plus and F minus. So all of these are Bronsted acid and base. All right. So please, acid, proton pair donor, base, proton donor, base, proton acceptor. So please take note of that. In our next class, I'm going to be explaining what is called conjugate base and its acid. Conjugate base. That is in our next class. Please note, the most acceptable of what acids and bases are was stated by Gilbert Newton-Lewis. The most acceptable definition of what acids and bases are was stated by Gilbert Newton-Lewis. He said that an acid is electron pair acceptor. An acid is electron pair acceptor, then a base is electron pair donor. An acid is electron pair acceptor by Lewis, base is electron pair donor. For example, if mercury, which is H plus, should react with cyanide, what will I have? I will have HgCN minus 2. All right, so this guy, don't forget, is always minus. All right, so acid electron pair donor, this mercury, right? This mercury, that is hydrargyrum, that is the Latin name, and this cyanide. So please, this guy is the acid, this one is the base. So what I've just illustrated is Lewis acid and base. So in our next class, we shall be looking at the conjugate base and the conjugate acid of a given compound. Do have a wonderful day. Please do not forget to subscribe, like, share, and comment. Do have a wonderful day.